Okay, hello. Good afternoon, everyone. My name is Chori, but I think, yeah. Today, I'd like to say about our project. The name is Piccolo, and the Piccolo is the mixed critical orchestrator for user space. But, yeah. Okay, I should say hello again. Yeah. I'd like to introduce myself. My name is Chori Lee. Just call me Chori. Yeah. Yeah. Sorry. Yeah. Just call me Chori. Yeah. I'm a project leader of the Piccolo project. I'm working in the LG Electronics, and I'm part of SDV task in smart mobility laboratory. I have been working in here over 13 years as software developer and software architect. I'm very happy to say about the Piccolo project, and I'm also happy to stand here as speaker. Okay, for next, I'll pass this button to my colleagues. Puitan?
Yeah, thank you, Cholhi. My name is Xavier Punithan. I work with Cholhi in the same lab, and I'm a principal research engineer in LG Electronics, and also I'm a member of technical advisory committee. I'm also very happy to be here, and we would like to introduce this project, even though the project name will be changed, but still it's a good time to introduce this project. So before going into this project, Piccolo, so why this project? So basically, there is a biggest challenge in the use cases and applications for the SDV, because whenever we meet OEMs or anyone else, what is that use case that we can do it differently in case of SDV? When we have an HPC and zonal controllers and things, what is that in application level that you can do differently? So that was the question raised by ourselves, and then we tried to find an answer. So that's how we wanted to start this project, and we would like to explain this project using several questions. So first, we will explain what is Piccolo, then what is the purpose of the Piccolo or the long-term vision for this project, and also how we are going to add value through this project to SDV Eclipse, and what are the core building blocks of the Piccolo, so technical blocks that will be explained by Cholhi. And also I will explain certain sample scenarios that Piccolo can handle. And then we will explain you the roadmap that we plan to do this year and also for the future. And finally, we conclude this project. So basically, Piccolo, what is Piccolo? Piccolo is a upper middleware software component. We would like to say that. And basically, it decouples the states, conditions, as well as policies from the applications and use cases, and orchestrate them using a manifest. So this is simple as that. By doing so, what we are doing is we are trying to make the application development is much more simpler, and so that we can provide the better customer experience. So this differentiated customer experience for the same application or the use case scenario, which I will explain later. So this is one of the major contribution that we would like to make it. So same use case scenario can be felt by differently by the different users as well as the different context and scenarios. So we call it as a user space mixer critical orchestrator for the manifest. So this is one of the point that we would like to clearly mention about this project. So what is the purpose or the long-term vision of this project? So basically, we would like to extend the mixed criticality properties to the upper layer, to the user space. So that is our main goal of this project. Especially, we would like to transform these mixed criticality requirements to the use cases and applications, especially the context and states and policies of the applications. And also, we would like to contribute an enabler for easy adding the functional safety and security levels. Because once the user is able to develop their applications, they also would like to add what level of the functional safety or the security they would like to add in a very simple way. So that also we would like to enable that. So next, what does the Piccolo add value for? How does the Piccolo add value for the Eclipse SDV? So the first value, we would like to address the customer experience of the SDV blueprint. So this is one of the major contribution we would like to make it. And secondly, we would like to transform and managing the workload requirements to the user space. So this is the second major contribution we would like to bring in. And then we want to add the value for the efficient, simple implementation, because we would like to make the implementation layer at the upper layer very simple, simplify it. So by simplifying it so that the developers will be able to develop their use case and application in a more faster manner and also in a more efficient manner. And also they can add and delete whatever the scenarios they would like to change it. So next, Cholgi will explain how this project coexists with other Eclipse SDV projects.
Okay, it's my turn again. See, as I know, in Eclipse SDV, there are some projects for orchestration technology, such as the Encheios and Bluetooth and Symfony. So I'd like to let you know what factors are the difference between the Piccolo and the others. So firstly, the Piccolo is not focusing on the cloud deployment. So Piccolo is not overlapped with the Symfony. Okay. And Piccolo is Piccolo is always focusing on the weak edge device. So let's talk about the vehicle case. On vehicle side, Piccolo is managing the service pipeline or the workload chain to enable vehicle scenarios. So Piccolo is not focusing on controlling or on managing each service and each container. In this perspective, Piccolo has the connection with the workload orchestrator, such as the Bluetooth, and the Encheios could be. And the Piccolo doesn't have the connection with the container runtime directly. So I think Piccolo is not the overlap with the Bluetooth also. So Encheios, okay, yeah. And lucky for Piccolo, actually we could have a chance to talk with the Bluetooth team and the Symfony team before this event. So I could have a conversation with them to make our collaboration and the making harmony together. So in my mind, so if it's possible, so I'd like to a conversation with the Encheios team also to after this session. Then I will talk more technical things for the Piccolo. Piccolo has the many four modules: API server, state manager, gateway, and YAML parser. Actually the YAML parser, the name is just not YAML parser, but the YAML parser that can parse YAML format files and the converting workload file for the workload orchestrator. So in this chapter, firstly, I will talk about the Piccolo architecture, and then I'm going to describe each modules with the diagram. And finally, there will be the sequence diagram for the simple use case. Okay, let's go. It's the Piccolo entire architecture. So there are four modules: the YAML parser and gateway and API server, state manager. It's green colored box. And you can see also the SCD. So SCD is for the maintaining the reliability for the Piccolo. And outside of the diagrams, there are the four modules also, the gray colored boxes. So these are for the testing modules. Okay. Let's go more deep dive. First item is API server. So as I mentioned on last page, Piccolo has the 4 modules. So first one is the API server. So API server can support gRPC interfaces for the external use. So it's like the Ankyos. And by using gRPC, it's possible to send a request to Piccolo. So, and API server can save some data in SCD and change the state also in SCD to maintain the Piccolo. This is diagram for API server. So API server has gRPC interface, as I already mentioned about that. And with the Piccolo TCL, the grade boxes module, you can send a request to API server by command line interface. API server also support to manage the resources defined by Piccolo project. Scenario is actually one of the resources. We would like to manage mixed critical properties and resources to enable vehicle scenarios. We would like, So API server have the features for managing resources. By just changing scenarios and policies, safety-related requirements are often overcome through the changing policies. So Piccolo support the feature that allows you easily update and easily manage the scenarios and policies. Next one is the state manager. It has connection with the workload orchestrator, and the state manager manages the transition between the state changes, so current state status to desired status. Its diagram for the state manager is similar to before the API server. State manager can handle 2 types of the messages. One is the command messages from the API server. Command messages. Can I use the the command messages, and the other is the messaging from the gateway about the scenarios. So it is for managing the transition of workload states. After receiving the messages, the state manager can make a request to workload orchestrator. And the state manager also can manage the shift from current state to desired state. And Piccolo has the Piccolo own gateway also. The Piccolo gateway can receive the vehicle messages or vehicle signals and triggers an event. And for considering the time to trigger the event, the Piccolo gateway register filters and register listeners for each scenarios and each policies. It's diagram for the gateway, and the Piccolo can receive the vehicle messages or the data from the gateway. This one, wait a minute, this one, yeah, vehicle data. And Piccolo, now the current version of Piccolo support the DDS protocol only. But in the near future, the Piccolo would support various vehicle communication protocols, such as the gRPC or the U protocol or the some IP. And the Piccolo can receive the vehicle data to trigger the event. So usually vehicle status is changing dynamically, and vehicle scenarios depends on vehicle signals or vehicle status. Piccolo can understand vehicle service, vehicle status, vehicle end service by receiving vehicle messages from Piccolo gateway. Currently the Piccolo is only supporting the DDS, but as I mentioned before, we extend the protocol coverage. Last one is YAML parser. So even though the name is just YAML parser, but it has more features than meaning of the name. It can support to convert workload for workload orchestrator. For this time, it can support to convert the workload manifest for the Voluti. For example, when receiving the Kubernetes YAML file, Kubernetes pan YAML file, it can make modified pan YAML file. The removed the something risky attributes and the making the a dot service for Voluti. It does not only support YAML file, but also support the workload manifest. And it also supports to pass scenario YAML file and register new scenario and to start the events. Okay, so long. This diagram shows the scenario resource, the resource in Piccolo. Okay, our scenario YAML has the three factors. First one is metadata. Yeah, metadata, and second one is conditions, and third one is actions. So when receiving scenario YAML file, Piccolo can parse and register it as scenario resources. So the information of resource is stored in the SCD and send a message about the metadata and conditions to gateway. Receiving the gateway make the register and the listener. And then the gateway set up the filters for receiving the messages from the vehicle data or vehicle signals. So when specific conditions are met, the Piccolo gateway informs the state manager. Here, state manager, and state manager can load the action data from the SCD, and state manager control the transition between the current state to desired state. Okay, this is sequence diagram for simple use case. Actually, as I already mentioned about that. So when the scenario YAML is received, and the data could be sent to API server, and API server save the data to on the SCD, and API server directly sent to gateway, and gateway make the listener and filter, and if when the condition is satisfied, it's sent to scenario name to state manager, and state manager read the actions from the SCD, and then state manager start the target scenarios. Okay, the Punta will explain the use case about Piccolo.
Okay, as I mentioned, basically the idea is to decouple the states, policies, and conditions from the application and use cases, so that we make the application developers to feel very easy to develop the use cases. So I will explain how Piccolo can help in developing an application scenario. So you can see that here, there is a same use case scenario. Driver approaches his parked car. But for this particular use case scenario, there could be two different contexts. So one context is that he starts from home and enters the car, manually opens the door, enters the car, and installs the DSM package for the first time at some time T1. And in the second context, the same use case scenario, but the user, he after picking up a cup of coffee from a cafe, then he is just entering the car at different time. So if you look at that, the use case scenario is the same. Driver approaches his parked car. But if you look at the conditions for the first use case scenario, so basically the driver enters his parked car from home, but the context one operations will consist of a driver recognition feature, which is enabled after installation of the DSM package. So if you look at the states, The first is door open. So driver basically open the door manually and installs the DSM package. Then he enables, so automatically the DSM system will be enabled. So it will go to the enable DSM state, and the in-vehicle camera operates, and then it recognizes the driver face. Then automatically it loads the personal information configuration and seating configuration and other things. So here, these are all the states and conditions that we have captured. And if you look at the second use case scenario, I mean the second context. So if you look at the second context, after the picking up of the coffee, he's approaching the car, but already there is a DSM package installed, right? Because it's happening at a different time. So now if you look at here, the conditions, actually basically the states are changed. The order of the states are changed in this use case scenario. So the enable use DSM is the first state where the out vehicle camera recognizes the driver, and then it automatically opens the door for the driver. Then once the driver gets inside the car, then his personal configurations according to that current status, it will get loaded. And then driver unparks his car from the parking area. So when he does that, there are two different policies have to be enabled. So if you look at that, the first policy, disabling the out vehicle camera, because the out vehicle camera will be used by the ADAS package. And second policy is enabling the out vehicle camera access for the ADAS. So these two different policies are managed. And if you look at this same use case scenario, but having the different states, different conditions, and also the policies. So these have to be parsed in a more, detailed way, which is done by the Piccolo YAML parser. And then we will be able to develop such kind of use case scenarios in a very simply we can develop it. So basically the idea is that the third-party developers, so as you know, as we go into the more of a platform-based SDV business in the future, so there will be a lot of millions of developers will be coming up and developing their own use case scenarios for the vehicle. So in that sense, Piccolo helps them to develop such use cases. But at the same time, they also would like to add the functional safety and security levels in a very simple level. Say, for example, high level security, high, medium, or low. So this kind of the security levels or functional safety levels can be added in a very simple way. So what we try to do is we just would like to make the development and use case development is a more simplify it. And that's what our implementation layer, we are making the implementation layer above the workload orchestrators. So this is our main goal. And so we would like to present the roadmap, like what we have developed until now and what we are going to do there. So in a completed scope of work, the Piccolo Bluetooth API integration is already finished, and also the manifest-driven scenario management is being completed, and support for the API server based on the GPR RPC also is completed. Then workload converters, basically the workload converters to and fro from the application to the underlying workload manager. So that also is being completed. So in this year, we would like to expand the scope basically for the workload orchestrator support, multiple support. One example is like we would like to integrate the Ankayas with the Piccolo. Then the second thing is the devices and the network access for the use case scenarios, because certain use cases would like to access certain devices and also certain network resources. So in this case, we would like to simplify it and make the use cases more easier to access these devices and network. And then we would like to add the workload chain based scheduler. So basically this can be done through the Timpani project. It's another project. In a parallel project we would like to start, and the outcome would be used, and even this name also would have to be changed in future. Now I will give the pattern to Sholhi, so he will explain what kind of the Timpani project will produce the outcome and how we are going to integrate it.
Actually, this is Timpani project, so it's just pen name. So as Punitang already mentioned, I think we should change the also. Yeah, Timpani is the workload chain based scheduler. So it could be contribute in maybe October. Is our plan, and it's focusing on making the time triggered scheduler for multi-node environment. Basically, the target of scheduling is workload chain, not the single service. Timpani has basically two features. The first one is Timpani support to make static scheduling table for the workload chain. Second, and the timpani also support to monitor and trace the status of scheduled workload chain. From these features, we can make a stack, the validation stack, to the deterministic requirements. So actually the timpani can run as standalone, but I think with Piccolo, it could be more powerful. And okay, so let's conclude the presentation. Yeah, let's summarize. Up to now, we have explained the Piccolo project. So in this page, I'd like to summarize our presentation. Number one, Piccolo have been started as open source project. And Piccolo have been working with the open source community. So Piccolo is making based on the open source based architecture. Number two, the Piccolo is always focusing on making the mixed critical orchestrator for user space. So as the managed properties increase, I think the coverage of mixed critical properties also expands. So increasing the mixed critical properties is our main purpose to work with the open source community. Third one is Piccolo is always the vehicle use case enabler. So we always focusing on how to enable the vehicle use case based on the container ecosystem and container the environment. Okay, so our presentation is over, and as I mentioned that as the pointer already mentioned, the Piccolo name should be changed. But even though it would be changed, it would be still Piccolo, and it's same as the Piccolo. So please remember that. Yeah.
Thank you.
Thank you.
Thanks a lot.
Yeah.
Any question? Question?
Question? Yeah. So nervous.
Question. Didn't quite understand why TD is to store, but it's distributed. And here I understand that it's all local now when you store.
Actually, we think in the future in the vehicle has the Juno architecture. So there are some modules, some issues. So yeah, this is the similar architecture, but actually the Bluetooth also have the agent and the server, so it's similar. But we already mentioned we are focusing on making the user space to enabling scenarios. So I think it's different.
More for the future that you can have multiple user space.
Yes.
Yeah.
Now it makes more sense.
So did I get it right that Piccolo basically uses vehicle signals to control the state of an orchestrator?
Yeah.
It can be,
Yes.
that is the summary. So it can use vehicle signals, whatever it is, and then change the state, start a workload, stop a workload, whatever that is.
Yep.
Yes.
Yeah. Correct.
I have a question on the mixed criticality. So you basically are isolating user spaces, and each user space can have a different safety level.
Okay.
Is that?
Okay. Basically the isolate the user space. It could be started from the operating system.
Exactly.
Yeah.
Yes.
So
Yes.
yeah. 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 So in that first perspective, actually the Libos, Red Hat the VQS has that features to isolate for the user space.
Yeah.
So we started from with the Red Hat team, the first.
Okay.
In the first perspective. So we I think we can make control the mixed critical properties based on user space, not to the operation system or the system hardware system. So we also have a plan to get a certification about the HLB or the functional safety level, but it's for the target is just the Piccolo project. It's not the whole the systems. Yeah.
So basically, the streamlined application development is what our major goal. So that will help really to develop the applications to decouple the kind of, like whatever the policies and states, everything we want to decouple from the application layer. So that means the application development would be like I mean, it's a long-term vision. The application development will be like logically like just if the user can say, okay, I want to develop his own user scenario, he can speak the scenario, and then we just capture it. Say, for example, I'm talking about a very long-term vision. So then you can create your own scenarios, driver, or the user. Yeah.
Thank you. Yeah.
Is there a plan to show a demo maybe next time? Or?
Yes.
Yeah. So actually,
Yeah,
we have some making the POC also, but I think we need to make the collaboration or under the Eclipse SDV also. Yeah. So I think we can make the next demo for next event or to end of this year. Yeah.
So Ankas is also part of our plan.
Yeah.
So, yes. Yeah. November. So
Yeah.
yes.
Yeah.
Yes.
Sure.